Okay, hello again, this is Mr. Steele. I'm here once again helping you with standards quiz questions. And this time we're going to look at standard number 5, which asks you to use and apply a bunch of the exponent rules all in one problem, in one expression, to simplify it down. Now normally I would do a couple examples and kind of talk through it a whole lot. With this one I'm going to do a little bit of talking and then I'm going to do the example and I'm just going to call it a day at that one. I think this one the instruction class is pretty good for, and it's really just a matter of doing it well. I don't think there's many people in class who don't understand what's going on. They just make little mistakes, or you just make little mistakes. So, excuse me. As we work through it, basically what we're looking at is an expression that has a whole bunch of factors, individual factors that involve exponents. So we're going to have to do a whole bunch of different things. In particular, things that I like to deal with first, as we talked about in class, is I like to deal with the negative exponents first. That's just me. For whatever reason, they're not one of the original rules that I learned for exponents, so I just like to deal with them. And the key with negative exponents is to realize that this is basically the rule. You have something to the negative m power, say a to the negative m power, that's the same thing as 1 over a to the positive m power. So negative exponents actually mean take the reciprocal, reciprocalize. I don't think that's a word, but it sounds good enough. So that's basically what you're going to do here. Same thing happens if it's on the bottom. If you have a negative exponent on the bottom, the exponent rules say to move it back up. And there's lots of really cool ways to show how this works and to use patterns. But again, I'm going to take that as a given that you've already seen that from our class. So instead, basically what I want to do is I'm going to start with negative exponents. I'm going to go into this problem, and everywhere I see a negative exponent on the inside, I'm going to move it according to one of these two exponent rules. So let's do that. It's going to seem a little weird, like I'm doing this in a little slow pattern, whereas in reality I would probably do a whole bunch of steps at once. It's for your benefit so that you can see each piece. Okay, so we're inside it. I'm going to leave the outside stuff alone. So first let's add some color here. So let's use this. So I'm going to circle all the negative exponents. So when I go to fix them, I can deal with it. So there's one, there's two, there's a third one, and of course we have this one on the outside that we're not going to have dealt with just yet. So now, on the inside of our expression, everything that's non-negative exponent is just going to stick around where it's at. So in this case, my fraction bar is fine. I'll have 24, I'll have 10 on the denominator, and I'll have this y to the third hanging on the inside. In green, I'm going to write all the things that have changed because of that negative exponent rule. So looking at it, let's start with this x to the negative 8. Well, it's x to the negative 8 on top. That means we're going to switch places and bring it down to the bottom. So it's become 8, or x to the positive 8 power. Now let's go, it's like this one, check. Second one, x to the negative 5, it's on the bottom, we're going to move it up. We'll make that x to the positive 5. In fact, a friend of mine that I went to teacher school with, Miss Hendricks, who teaches at Cosumnes Oaks, she always talked about it as like the neighbors, they're the what's the word for it? They're the angry neighbors. They're never happy. So basically they're negative, and so the way you can appease them and make them feel better and make them complain less about the cable and stuff is to have them move places. So this negative neighbor downstairs, move him upstairs, all of a sudden he's happy as a clam. The guy upstairs that's upset, you move him down and everyone's cool there too. So that's exactly what we're doing. We're just switching places, making them positive. Because again, if you move the neighbor and give him what he wants, he seems to be happy. Okay, next we got this guy already. Y to the negative 11th on the bottom. We're going to move that guy up to the top. And so now in green you can see all the pieces. The three things that were moved were right there. Now, we still do have this negative exponent on the outside. That negative exponent means the same thing, but it does have its own kind of exponent rule. The one that you basically will see here is that if you have x over y, so two different things on the inside divided, and they're to a negative power, like say negative m, that's going to flip them on the inside. Each one is going to have that negative property and move places. Then it will be taken to the positive m power. And of course, after that, we could use normal exponent rules to simplify it. So that's going to be my next step, is let's deal with that outside one. And in fact, I can leave it in green. I know what I'm doing. So right here, moving on down. So right here, since I've got a negative on the outside, I'm going to go ahead and do that same thing. I'm going to flip the inside, and then I'm going to make that outside exponent positive. So now everything that was on top is going to go down to the bottom. I'm not going to change any of it, I'm just going to move it. So 24, x to the 5th, y to the 11th, y to the 3rd. So notice everything is in green now because everything has changed places because of that negative exponent. What was on the bottom is now on top. So 10, x to the 8th is now on top. We're ready to move on with the problem. Well, our next piece, now that we've got all the negative exponents gone, there's not a single one hanging around in this problem. The next thing that we're going to do is we're going to simplify according to the normal exponent rules. So we'll have to look at the individual factors and kind of see what we can do to simplify them. So in particular, we'll do this. We'll have to deal with these x's, right? Oops, my circle's not very good. We'll have to deal with these x's. We'll have to deal with these y's. And just like anywhere, we'll have to deal with this pair of numeric factors, as well as that 2, but we'll start with factors on the inside. Okay, so what's next is let's use that exponent rule. So 10 over 24, how can I simplify that? Well, they both share a common factor of 2, so let's just simplify the fraction. That's going to become 5 over 12. Next piece, we got x to the 8 over x to the 5. There's an exponent rule that says, in fact I'll use x's, if we have x to the m divided by x to the n, basically imagine there's just n of these things canceling with the top part. That's just going to end up being x to the m minus n. And again, there are other great videos on YouTube that you can watch explaining why these exponent rules work. We're taking for granted that you've already seen them because I showed them to you. So here we've got x to the 8 over x to the 5. That's going to become x to the 8 minus 5, which is going to be x to the 3rd. That's going to stay on top. And of course the x's will end up where the bigger number was. Finally, down here, there is another exponent rule. If we have x to the m, and we're multiplying that times x to the n power, well again, each one's just a count of how many x's are being multiplied together. So the product will be x to the m plus n power. So you add the exponents. Down here, y to the 11th, y to the 3rd, y to the 11 plus 3, which is y to the 14th. And there we go. We've now simplified it. We only have one of each kind of factor. We've got x to the 3rd, we've got y to the 14th, we got 5 and 12 with no common factor. Now we just have to go through and square it. So let's find another color. Let's go back to black. Okay, so our last piece then is just to deal with this squared part. So what we're going to do is we're going to kind of adhere to this exponent rule right here. If we've got something divided by something or something times something taken to a power, each thing individually is going to be taken to that power. So in particular, we're going to take this 2 and we're going to square every single thing. We're going to square the 5, we're going to square the x cubed, we're going to square the 12, and then we're not going to square the y to the 14th. No, I'm just kidding. Of course, we're going to square y to the 14th too. Why wouldn't we? Why would it get a free pass? And so there we go. Got each of those. Once we've done that, this 2's kind of in there. It's like we've brought it into each of the exponent pieces. Now we just need to simplify what we have. So, neglecting how poorly drawn that line was, that's better. Now I can go through and just simplify each one. 5 squared, that's 25. X to the 3rd to the 2nd power. Well, x to the 3rd to the 2nd power is just going to be multiply the exponents, because again, this is another one of our exponent rules. Like we have this, we've already figured out why this works. We just know what it is. We multiply them. It's going to be x to the 3 times 2, which is x to the 6th. Down to the bottom, 12 squared. 12 times 12 is 144. And y to the 14 to the 2nd power, that's just y to the 14 times y to the 14th. You can kind of see why it works. Otherwise, we multiply the exponents. We get y to the 28th power. And this guy, 25x to the 6th over 14y to the 28th, is our final answer. And we got there just by using a slew of different exponent rules. In fact, I think I probably hit every single one in that example. In particular with the negative exponent rules, to be careful, make this a little easier to work with. And then by the end of it, we were able to simplify this down, so we only had like one of each type of factor in there. We had x to some power, we had y to some power, and we had some numbers that couldn't be simplified. And so there we go. The exponent problem number 5, really just a matter of executing and being careful, and not trying to do it all in one step. Like even me, like I don't do this in one step. I try to do it in a couple steps, so I make sure I don't make any silly mistakes, because there's lots of little pieces and arithmetic and stuff floating around. So anyway, I hope this video has been helpful to you. I'm not going to do a second example because I'm sure that you can, and you can probably just make one up yourself if you want to. I mean, that would probably work. And anyway, so yeah, I hope this video has been helpful, and I'm going to leave you there. So this is Mr. Steele, signing off. I did it with the eyes again. Gotta get that eye right. There. Well, that's okay. Have a good night.